So, okay, this question number 13, it's a miscellaneous kind of question. There are many concepts involved in this question, and at a glance, it looks like this. You got parts A, B, C, and D, and everything starts from expression two complex numbers that are given here. U equals to 6 minus 2 iota, and W is equals to 1 plus 3 iota. And then we got different things here. I think it would be better if we start working on it. So let's look at the part 1 here. Part A. Part A is pretty straightforward. I won't spend much time on this. We can straight away write like this: U plus W. So I got U plus W. I get 7 plus iota. Then I got conjugate of U, which is 6 plus 2 iota divided by iota W. So iota and W is equals to 1 plus. And I can quickly work with this, multiply this numerator. I get 40 plus 20 iota divided by minus 3 plus 1 and minus 3 plus iota. And to write this in a form which helps us in finding its mod, we need to get rid of this complex number from denominator. So multiply with the conjugate of that. Then when we multiply this, we get 40 times minus 3 is 100 and minus 120 plus 20. So basically you get minus 100 here. And then I get minus 60 and minus 40 is minus 100 iota divided by 9 plus 1, which comes from 3 square plus 1 square, and this gives us minus 10 iota. So if you want to now find mod of this, all you need to do is you do minus 10 square plus minus 10 square, which basically is 10 raised 2 as was required there. Okay, look at part 2, part B. Now part B, this Z1 has already been converted into the polar form here, so we don't need to work through this. It's already given that Z can be represented like this in polar form, and we have been told that we need to find the complex number, distinct complex numbers Z, such that Z cube equals to Z1. So what is given is that Z cube is equals to Z1, which is 200 to the power 1 over 2 6 minus 3 over 4. Okay, all we need to do is we need to solve this equation so that we get the values of Z which satisfy this equation. So let's work like this. So that means that, sorry, not good looking Z there. So Z is equals to what we are doing is we are raising both sides to a power of 1 over 3, and that gives us 1 upon 6. Okay, but before we do that, we need to generalize this statement. So I'm going to clean that up, and let's see. Let's say that Z cube is equals to 200 1 upon 2. The thing is that this is a periodic function because it consists of sine and cos. So we can add 2k pi here. And now we take cube root of both the sides. So that gives you Z is equals to 200 to the power 1 over 2 cis 1 over 3. That gives us 200 to the power 1 over 6. And cis, what we're doing is we have used de Moivre's theorem. 2k pi So here, just like in problems on roots of complex numbers, k will take different values, and depending on different values of k, we will get different values of z. So basically, we'll get many different roots here, and because we are taking the cube root here, we'll see that we only need to use any 3 consecutive values of k. If we use more than 3 consecutive values, then the roots will start repeating. So we'll take the values of k. We'll take 0, 1, and 2, and accordingly we'll find 3 different roots, 3 different values of z here. So first one, when I take k equals to 0, I'll call that root 0, and that will be equals to 200 to the power 1 over 6. It becomes 1 over 3 minus 3 over 4, or I can write it like this. That's my first root. When I take k equals to 1, my root, the value of z, second value of z, which satisfies this equation is, we got this here, cis 1 upon 3 minus 3 pi over 4 2 pi, and that gives us z1 equals to 200 to the power 1 upon 3, and this is 2 pi minus 3 pi over 4. So what you get is 8. You get 5 pi over 4, and that will be cis 5 pi over 12. Okay, this is my z1, and next value that I'm going to take for k is k equals to 2. That gives me my third value for z, and I'll call it z2. It's these kind of questions are not difficult. Cis 1 over 3 minus 3 pi over 4 plus 4 pi, and that gives you 1 upon 3. 16 minus 3 is equals to 13. Which gives you cis 13 pi over 12. Now if you look at this, this root here, it's 3 pi over 12 basically. If this value lies outside the domain prescribed for argument, so we need to convert that into we need to write it in such a way that it falls in the domain. So if we just draw it on the graph here, 13 pi over 12 is 1 pi and then pi over 12 more here, so basically it is here, and that angle is pi over 12. So, and it has gone beyond pi now, so instead of showing this angle, we need to show this angle, and then it will be a negative argument. We can obviously see that because this small angle is pi over 12, so the angle from here to here will be 11 pi over 12, and that would be our argument for this third root, and this will be, or you could do a minus 2 pi here, so we'll get 11 pi over 12. So these are the 3 roots given there. Next part is showing all these possible values of z on an Argand plane. So we see that the length of all these vectors, the mod of these all these complex numbers is 200 to the power 1 over 6. So our three roots will lie within a circle of that radius, and then we'll need to just show the angles and mark them on the Argand plane. So let's first draw a circle here. So that's my real axis. Don't forget to write RE and IM here, and I'll say this is my circle. So I've taken 5, 1, 2, 3, 4, 5 here, 1, 2, 3, 4, 5 here, and 1, 2, 3, 4, 5 here. Okay, so and there you go. So first root, your z0 is, and the radius of this circle is r is equals to 200 to the power 1 over 6. And first root was, if you recall, it was this here, minus pi over 4. So minus pi over 4 will be here, this angle here, exactly in the middle. And this angle is pi over 4. Easy enough. And next root that we found was 5 pi over 12, 5 pi over 12. So 5 pi over 12. Pi over 12 is, we can convert these into degrees so that we can look at them properly. So pi over 12 is 180 over 12 is 15. 15 times 5 is 75. So that angle is basically 75. So it will be somewhere here. And that angle is 5 pi over 12. And the third root that we found is minus 11 over pi, minus 11 pi over 12. So 11 pi over 12 minus pi is, minus pi comes here all the way. Up here it is minus pi. And we only want minus 11 pi over 12. So it will be 1 pi over 12 less from here. So we come back here. Pi over 12 is 15 degrees. So it will be something like this here. That angle will be pi over 12. And we can just nominate them. So this is my W0, sorry, not W. Oh, sorry. So Z0, Z1, and Z2. Now here you can wonder whether the roots that you found are correct or not. All the roots of a complex number basically lie at equal angular intervals on the Argand plane, or in other words, they should be uniformly distributed. I'll repeat that. It's really important. The roots of complex numbers are uniformly distributed on an Argand plane. So we got three roots here, and we are right if angle between each of them is 120 degrees, and we can verify this. So this angle between Z0 and Z1 is 5 pi over 12 and pi over 4. So 5 pi over 12 is 75 degrees. So we can just check. I will just check only this value. Other values you should be able to check on your own. So 5 pi over 12 equals to 75 degrees, and this angle is pi over 4, which is equals to 45 degrees. So total angle between Z0 and Z1 is equals to, you add both of them, and that's 120 degrees. So this is 120 degree here, and likewise, or if you want to write in terms of in radians, then it is 2 pi over 3. So same will be the angle between Z1 and Z2, and Z2 and Z1, Z2 and Z0. So basically, that tells us that we have determined the roots correctly. We don't need to write this thing here. That was just for us to check. Move on to question number 4. By expressing u, let the argument of u be given by arg u equals to minus alpha. So we don't need to find alpha, or we can write u. Now we need the values of u and w, so I'll just write these values of u and w for our reference here. So we'll need to go back and see u is equals to 6 minus 2 iota and 1 plus 3 iota. Yep, did I get them right? Yep, 6 minus 2 iota, 1 plus 3 iota. That is right. So we can write here that u is equals to 6 minus 2 iota is equals to, I'll just write mod u cis minus alpha, because that's argument of u is already given here. It is minus alpha. Now the question is asking us that we should express iota w in polar form in terms of alpha. So we need to think, how can we express iota w in terms of alpha? It indicates, basically, if you think, it indicates that iw is related in some way to u, or in other words, iota w could be derived from u. So let's see how we can write w as. Let's scroll it a little bit up there and draw a line, divide this area into 2 so that we can work on it. Okay, so w is equals to, iota w is equals to iota 1 plus 3 iota. That gives you minus 3 plus iota, and I'll write that as minus 3 minus iota, which I can write as minus half 6 minus 2 iota. So basically this is u here. We can see that minus iota w is related to u here, and this u we already know what it is as written here. So I've drawn it, I can clean that up. As written here, we can write it like this: mod u cis minus alpha. We can write like this, and minus this minus 1, minus, in place of minus I'll write cis pi, because cis pi is equals to minus 1. That gives you half mod u cis pi minus alpha. Okay, so that part is all right. Now we are looking at this expression, and that's what we need to determine. So we got two values. We got u, we got the numerator here, and we got the denominator here. We just need to divide them and we should be home. So mod u divided by iota w. So mod u, numerator is not given here, this is only u here. So we need to write the conjugate of u here. This is conjugate of u. So to find the conjugate, you just change the sign of the argument. So the numerator will become cis alpha, and iota w is what I got here is what we get here. I'll write this thing again. Mod u cancels out. You got a 2 here. Cis alpha divided by cis pi minus alpha, which basically becomes cis alpha minus pi minus alpha. Sorry, it hasn't come out really clean, so that gives you cis alpha minus pi plus alpha is equals to 2 cis 2 alpha minus pi, and that's what you require to find. Easy thing. And the next part is using the relation given in part A to find arg u plus w in terms of alpha. So what relation we were given in part A. Let's go back and take a look. So the part A is this. You got Z1 equals to U plus W. This is the relation given to us. So we'll write that there for ready reference. So what we have here is, from part A we are given U plus W, U bar divided by iota W. And from part A we know that this is equals to minus 10 iota, or I can write that as 10 root 2 cis 3 minus 3 pi over 4. Alright, so when we look at this, we got U plus W, conjugate of U divided by iota W. This part, conjugate of U divided by iota W, was what we found in part C. So I'll write like this. Now this part here, U conjugate of U divided by iota W, we already found in part C here, so we'll use this. We found that is equals to 2 cis 2 alpha minus pi. So this is my U plus W, 2 cis what was that, 2 alpha minus pi, sorry. So 2 alpha minus pi. Which means you need to U plus W, you divide on, you basically separate this. Which gives you 5 root 2 minus 3 pi over 4 minus 2 alpha minus pi, and that becomes minus 3 pi over 4 minus 2 alpha plus pi. That gives you U plus W equals to 5 root 2 cis, this you got pi minus 3 pi over 4, which basically is pi over 4. So our answer is pi over 4, and therefore just remember what we are trying to find. We are trying to find arg of U plus W, and that will be pi over 4 minus 2 alpha, and that's what we were trying to find.